Okay, hi there, I'm Howard. This is just another video of me solving a numerical problem. So insert interval. So we're given an array of non-overlapping interval. The interval where interval I star and n represent the star and n of the I interval. Interval is sorted, okay, which is very important here. It is sorted in ascending order based on the star count. Okay, we are also given an interval, new interval star and n that represent the star and n of another interval. So we just need to insert it in the correct place, right? And then we need to do the merging and make sure there's no overlapping interval if when we after we insert the new interval, right? So insert the new interval into the intervals array such that interval is still inserted, right? Ascending order by the start, and interval still does not have any overlapping interval, like merge overlapping if necessary. Okay, so the first thing we can do is we can figure out the index, right? To insert this. So we can do a linear search, right? Because it is sorted, so we can use binary search, right? We can have left and right, right? So which is our mid index is here, by 6. By 6 is larger than 4, right? So we set the right pointer to here, right? Wait, now our mid index is on the left, right? Over here. So 1, 1, and 4, right? 4 is greater than 1, right? So we want to move our left pointer to the right. The left pointer equal to the mid, right? Plus 1, which is here, right? So now left and right are equal to each other, right? So our mid still is gonna be here, right? So 3 and 4, right? 3 is smaller than 4, right? So we want to move to the right, right? So we set the left pointer equal to the mid plus 1. So it is here. So now they are overlapped, right? So we just break the while loop. And the left here will be the index, but we're gonna insert the new interval, right? So 1, 3, and then 4, right? Which is at index 2 here. Okay. So we can use binary search to find the place to insert, right? So that is log of n, but we need to insert it, right? Which is gonna take us O of n because we have to reassign the indices if necessary, right? So that's O of n. So yes, we can just ignore this term, right? So our time complexity would be O of n. For the space complexity, right? Uh, we need a new word interval, right? To store to return it. So that is O n space. Okay. So first thing first, let's just figure out the place to insert the new interval, right? And then we can worry about the overlapping later on. Okay, so binary search, right? We have left and right. So y left is just gonna equal to right, and then we're gonna do mid right equal to left plus math explore of y minus left, right, divided by 2. And then new interval at 0 is greater than. So this is new interval 0 is the start time, right? If it is greater than the intervals at mid, right? So this is the middle interval. It is the new interval, and we're looking at index 0, which is the start time, right? If it is greater than, if the new interval is greater than the current interval, right? The mid interval, we want to go to the left, right? So we're gonna set. Oh, sorry. If the new interval is greater than the mid, which means you want to go to the right, right? So if you want to go to the right, you have to set the left pointer equal to mid plus 1. Yeah. Otherwise, you want to go to the right, which is the right pointer equal to. Otherwise, you want to go to the left, right? So to go to the left, we need to set the right pointer equal to mid minus 1. Okay. Okay, so if it is greater, we go to the right by updating the left. We want to go to the left, we update the right. Okay. And then after that, we can after we break the while loop, which means left and right are overlap. right? And the left index will be the index that we will insert the interval, new interval, right? So you can insert the left, right, using the left index here. Slide, which means we delete zero element at the left index. We're gonna insert the new interval. Okay. Okay, now we need to make our new arrays and store our intervals. So now we're gonna do the merging, right? We will return our merge interval at the end. Okay. So how do we merge? Um. Okay. So let's take a look at this example. This uh interval, for example, right? We're gonna have 1 and 2, uh 3 and 5. So we insert the new interval here for 4 and 8, and then 6 and 7, I believe. Yeah, 6 and 7, 8 and 10, and then 12 and 6. Right? So this will be our interval. So we're gonna have our merge interval, right? Merge. So let me just point this here. So it's gonna start out with the first interval. 1 and 2. Okay. Okay. So as we iterating through, we can start at the first index here, right? As we iterating through the interval, we're gonna check if the start time, right? If the start time, the current start time, if that is greater than the last end time, right? If the current start time is greater than the last end time, which means we found a new interval, right? They are not overlapping. If the current start is bigger than the end, right? The last end, which means there's no overlap. We found a new interval. So you're just gonna go ahead and add it to our interval array. Okay, so let's do that first. So starting from the first index, intervals of length, and then I plus plus. Okay, so so if current star, right, is greater than the last end, and we want to push it, right, to merge interval that push the intervals at I. Right, interval at I here is the sub array, right? Intervals at I here gonna be the sub array, right? This interval is interval. Okay. So what is our current star? Our current star gonna be we also need the current n, right? So our current star and our current n is just gonna be equal to interval at I, right? Current star and current n, right? So the intervals I is 3 and 5, right? So the current star gonna be 3, the current n gonna be 5. Okay. And what is our last n? Our uh last n gonna be the merge interval, right? At the last index, right? So if we look at the merge interval, right, which is this array right here, we look at the last index of that interval, right, which is so before we even inserting this, right, this is what we are looking at, right, which is the last index, right, and we're looking at index 1, which is the last n. Okay. All right. So what is the last index? The last index is going to be the merge interval dot length and so on. Yeah. Okay. All right. So yeah, we iterating through the intervals array, right? After we add the new interval, right? If the current star is greater than the last n, we found a new interval, and so we just add it in here. Okay. So let's continue to look on the next one. All right. So we are looking at what? We're looking at 4 and 8 now. Okay. So 4 and 8. So is the current star bigger than the last n? No. The current star is smaller than the last n, right? So we have 3 to 5, 3 to 5, right? and 4 to 8 is like this, and 4 to 8, right? Which means we have some overlapping, right? We can merge 3 to 8, okay? So if the current star is less than, so if it is not bigger, which means it is less than or equal to the last n, right? Which means we might want to merge, right? So when do we want to merge? We're not gonna want to merge if it is completely overlap, right? So for example, this is our interval, right? What if the 4 and 8? What if the interval we want to merge is 4 and 5, right? So 3, 4, and 5, right? So if it is completely overlap, we don't want to merge, right? We just want to ignore it, right? Because 3 to 5 is the same as is already contained the interval from 4 to 5, right? So we don't want to merge if it is completely overlap. So we need to make sure that the last n is, sorry, we need to make sure that the current n is greater than the last n. Okay, we need to make sure the 8 here is greater than the current n, the 8 is greater than the last n, right? If it is smaller, like 5 or 4, right, we don't want to merge. We just want to ignore that. Okay, so yeah, as if the current n is greater than the last n, then we want to do what? We want to look at the last index, right? The index 1 equal to the current n. Okay? So in this case, the current n, right, is bigger than the last n, right? So you want to look at the last element in the merge interval, which is this one, right? And we're gonna look at the first index, which is the 5 here, right? Right, and we update it to the current n, which is 8, right? Update it to the current n. So now we have 3 to 8, which is we successfully merge this interval, right? Okay, so we just keep going, right? Now we have 6 and 7, right? Okay, this is the perfect example. So the current star, right, is not greater than the last n, which means we might want to merge, right? We don't know yet. We might want to merge. But if when we look at the current n, which is 7, it is less than the last n, right? Which means this interval is already inside 3 and 8, right? So we don't want to do it anything. We want to just ignore it and move on to the next one. Right? Now, the current star is not greater than the last n. Right? So we want to merge, so we check the current n, right? It's bigger than the last n. So we merge, right? We update the last elements. We update index 1 of the last element. Right? So we update the ending time of the last interval. So this becomes 10. This becomes 10. We move on to the next one. So now the current star is bigger than the last n. So we just add this new interval, right? And then it is what we have, right? So the output, and we can return that. Okay, and that's pretty much it. Yeah, let's run this. Accept it. And thank you for watching.